All right, so the next step in our process is for us to start working through sort of how do we write math? Like, what are like the nuts and bolts of actually doing this thing? Um, and so what I'm going to be doing is sort of going through a guide to writing math. And I do want to be very, very, very clear on this. All of the presentation that I'm doing here and the parts of this that are coming up are really heavily based on the work of another person, Dr. Kevin P. Lee. There is a document that that he put together, that they put together. I'm going to put a link to it in the YouTube video that's linked here, as well as anytime I use this assignment. I just want to be very, very clear that the ideas that I have here are not my own. This is someone else's work, and it's very, very well done. And so I'm really just kind of coming up with a video multi-part presentation of that work that Dr. Lee did. So one of the first things that they talk about in this guide is the idea that we need to follow the rules of grammar. You all are used to math being just equations, but you're starting to understand through this class and through what we've been talking about that writing also has its place in math. And the reality is, any good writing that you do should follow the rules of grammar. Like, you should avoid sentence fragments. You should sort of like do all the things that we need to do in order to have good writing. And math writing is no exception to that at all. One thing that can make that confusing, though, is that mathematical writing also includes equations and symbols and all kinds of other things that you may not be used to seeing, like incorporated into sentences or being sentences, or sort of thinking about what the grammar around those things would be. The good news that I have for you is that the formulas, the equations, the expressions, the things that we do in math all literally follow the same grammatical rules that apply to words and to sentences and to phrases and to things like that. So it's not like you really need to learn a ton of new grammar to write math. It's just about recognizing that these mathematical objects that we have follow the same rules of grammar and then practicing using those things. And so one way that we can do that, or to sort of think about that, is this idea of thinking about parts of speech. And I hope I'm not super stressing anybody by making you think about times that you had done sentence diagramming or anything like that. I've always actually really enjoyed sentence diagramming. But even if all I talk about today is the idea of parts of speech in terms of nouns and verbs, right? I expect that you all know that a basic sentence is essentially made up of nouns and a verb, right? So as a super simple example, if I have the sentence, the student is human, the words student and human are nouns, and our verb, like the one main verb in our sentence, is the verb is, okay? In mathematical writing, symbols and expressions can correspond to different parts of speech, right? So for example, if I have that right there, right? That collection of of 8 symbols, 3 plus 5 equals sign 8, period. That in total is a sentence, okay? We can tell that that equation above is a sentence because it has a verb, right? What's the verb in that sentence? Right? You might be inclined, and I hope you got it right. I hope you're like saying this out loud to yourself. You might be inclined to think that it's plus because plus sort of has like a little bit of like a verb feeling to it. But if I were to just say 3 plus 5, like if I said out loud to you 3 plus 5, that's not actually a sentence, right? If anything, you might even, I guess you might treat that as kind of like a question. The verb in that mathematical sentence up there is equals, right? Equals is a lot like the English verb is, right? So when we say 3 plus 5 equals 8, that sentence feels a lot, like grammatically, like the sentence up above, the student is a human. You're sort of saying the student is equal to, and then a human, similar to below. You've got 3 plus 5 equals 8. Okay? And so I want to sort of point out to you, I know that this is a little bit weird, but writing 3 plus 5 equals 8 is a complete sentence in English. In fact, when we say it out loud, It even sounds like a sentence. 3 plus 5 equals 8. Period. Since it's a sentence, we end it with a period. Okay. Now, I do want to point out that not every mathematical expression will be a complete sentence. If it doesn't have a verb, just like in English, it can't be a complete sentence. And so kind of like I mentioned before, just saying 3 plus 5 is not a complete sentence, right? So similarly, if I had something like x squared minus 5x plus 17, like, saying x squared minus 5x plus 17 is like saying the student. It's like, well, the student, what? The student is something, the student wants something, the student needs something. When I say x squared minus 5x plus 17, you're like, okay, that equals something, that is less than something, that's greater than something, this thing is not divisible by 5. Like, what do you want to say about it? What verb are you going to use along with this thing? Okay, so I just realized I did my presentation there a little bit out of order. Hopefully you understand why that thing is not a complete sentence. Yeah, if not, I hope you'll write that down as a question and that you'll let me know. And then again, I did my presentation out of order. Since this thing didn't have a verb, it doesn't have an equals, a greater than, or it's not part of a larger sentence, it has to be treated as a noun. It's going to be treated as a part of some other thing that we can still, it's not like that's bad and we can never write that in a paper, but that needs to be part of a larger sentence. So I now want to sort of get into some examples of this, and these are still going to be really simple, just in terms of looking at, is this thing a complete mathematical thought, or is it just a smaller thing that needs to exist? Oops, my face is in the way. So for each of the following, I want us to take a moment to determine if the mathematics that are written are a complete sentence, or if it's a sentence fragment that would need to be included in part of another sentence. So pause the video for a moment, consider these three things, decide for yourself if these are complete mathematical sentences, or if they are essentially sentence fragments, mathematical expressions that need to be included in part of a larger sentence. All right, so hopefully you noticed that the first one is definitely a complete sentence. And again, one of the ways that we're going to see that and hear that is by saying it out loud. When I read 4x squared y minus 15x is less than or equal to 37, like the English verb is literally shows up in there. Is less than or equal to 37. Okay, so the first one is a sentence. Yay. The second one, the square root of 5x minus 17 is not a sentence. That's a sentence fragment. That's a mathematical expression that we would need to put with other things to make it a complete sentence. And then the last one, 4 minus x is less than y, that one is a sentence. Okay, and I sort of already said this out loud, but I'm going to say it here just to make sure that I'm clear about it. One of the easiest ways to determine if math is a complete sentence or not is actually to read it out loud. Your ears will likely be able to hear if something is off in your writing. And so I know that teachers are often saying that students need to proofread their papers and go through and read their papers when they're done with them. This honestly could not apply more in any subject than math. In math, it's so important that you go back and read, and by read, I mean literally reading it out loud, reading it to yourself, reading it to another person. Even if that person doesn't understand math, we hope that your ear will hear, hey, whoa, something's wrong here. I need to go back and edit that. Okay? Oh my gosh, my face is really in the way of this one. What I've done here is I took a part of a mini math exploration that I actually shared with all of you and that most of you have seen. And I wanted to sort of go through it and read it to you line by line and sort of talk about a few different things here in the writing. The best way to get better at math writing is to write math, but that's hard to just sort of like dive into. So the next best thing you can do is read math. And so again, you've read this before, but I wanna point things out to you and hopefully show you a few things, as we're looking at this. Can I get like a laser pointer here so I can point at things? Okay, good. So one of the things that I wrote in this paper, we will look at the algebraic proof first. What I'm doing when I write this is I'm sort of letting people know this is what we're about to do. It's almost like I'm providing a little mini introduction to this paragraph. Also notice that I use the word we. Lots of times students will worry like, oh, am I allowed to use I? Am I allowed to use we? Can I use the first person? In math, most definitely. I in other subjects it might be taboo or not a good idea to use first person. In math it's often recommended, so you don't need to use stilted language like one should look at an algebraic proof first. We're just going to use we. Mathematicians, we're very personable. We want to work with people, so we will look at an algebraic proof first. The next thing I did, this word right here is really powerful. The word let is a word that lets you know that you're about to define something. So right here I say let a be a positive integer. So okay, we now know that a is an integer. It's a whole number and it's positive. It's not zero, it's not negative. The next thing I do is I sort of do more introduction. I tell everybody, hey, this is what I want to show. We essentially want to show that a plus 1 squared equals a squared plus a plus 1. Period. Right? This thing is a sentence on its own, but I can also make that sentence part of a larger sentence. Right? And just in case you're worried that you can't do that in English, you could totally say something like, we know that that person is a good writer. Okay? That person is a good writer is a sentence on its own, but I can say, we know that, and the word that, like, it introduces this, like, clause that fits under the sentence. And I don't want to get too much into that grammar, especially because some of you might not be a fan of that. But that's essentially what's happening here. We essentially want to show that, and then you write the sentence that you want to show. Okay? Notice that I'm taking this piece of math, because it's, like, this is a hefty piece of math, I'm going to give it its own line, right? So I give it its own line, I make that thing centered, and then I end that sentence with a period. Okay? And then I'm sort of explaining my next step. Using basic polynomial multiplication, I'm going to expand a plus 1 squared, right? So this is the thing that I want to show in the end. So now I'm starting somewhere else. I'm taking this a plus 1, I'm squaring it, and then I'm writing this thing out. Notice that I end this with a period again, right? Now, I want the reader to notice something, and so I tell them that, but look more closely. With an intentional rewrite of the right-hand side, we can see that, and I sort of like, I break this thing down into a smaller piece, and then I actually did more than that. I sort of like put some grouping marks here, and I used some color. I'm going to be honest, I'm not super excited about how I use the color here, because the color doesn't refer to anything. I should have done more with that. I should have said, aha, look up above that this is the red part, and look up above that this is the yellow part. Yay, I showed what I wanted to do. I at least went and said that. This is precisely what we wanted to show for our proof. And so, again, I'm communicating with the reader. I'm writing what I want them to think and what I want them to notice. At the end of this, I basically do a little bit of summary. The square stepping method tells us that if we want to square an integer x plus 1, we take the next lower square, x squared, and add to it the lower integer x and the integer 1 larger than that, x plus 1. Okay? So again, I'm basically providing a proof here. You'll notice that I didn't make x plus 1 its own line. I didn't make x squared its own line. And the reason for that was, I could have, but I think I just felt like that would have broken things up too much. We tend to reserve things being on their own lines for being sort of important steps in mathematics or important equations. They don't always have to be equations. They can be just fragments. But these were small. It seemed like it fit well enough to put them right in the mathematical work that we were doing. And so that's why I made that choice. So I hope that reading through this helped you to sort of like see and hear this a little bit more clearly. So the next step is, practice, practice, and sometimes that means read. The next step in the process of growing as a math writer are to read math and to practice writing it. So in the coming days, we're going to continue to read these mini math IAs that I'm producing, and very, very soon you'll be coming up with an idea on your own for a short piece of mathematical writing that you can do. So if you've got some ideas for those already, I'd encourage you to share those with me. I think that getting a chance to see and hear those would be a good thing. Yeah, so there are going to be more videos like this one where I go through different components of good mathematical writing, and I hope that those will continue to be helpful to you. As always, if you've got questions or if you have comments, please let me know. Yeah, happy to be here with you.